So like I said in the past session, we had covered the topics for Ethernet and the UDP. So in this session, we would be covering for the IP. So before we begin with IP, I would like to introduce some basics on the networks, packets, and the protocols that we are using. So what are basically networks? In this networks, I'm not particularly talking about the internet. I would request audience to keep their microphones on mute so that there won't be any disturbance. I would request DE-CIX team to mute the audience who are currently speaking right now.
बस इथे चेक बस तू काय सांगतो काय का ट्रेनिंग आहे तुमच्यासाठी.
Okay, thanks. So talking about the network, currently I'm not talking about the internet as of now. So you're very well aware that we have a road network also. What happens with the road networks is connects the different cities using the roads and the cars, wherein we commute and travel to different cities and different destinations. That's an example of a road network. The second type of network that we are aware of, that is the railway network, wherein it connects to the different railway stations using the railways and the trains to travel to different destinations. And the third type of network that I want to talk about is the electrical grid network. For an example, which connects the producers of the electricity to the consumers of the electricity. In today's time, we also have solar powered electricity also using at homes. In that case, it's not relevant, but in general case, the producers and the consumers of the electricity are connected with each other. This is an example of the electrical grid. Now, there's also one example of the postal networks wherein the senders are connected with the receivers through letters and packets. So packets is a good term to start off. So I'll just talk something more about packets. Let's say in the earlier time you were using the postal network, okay, and you want to order a garden shed. Garden shed is basically, this is the photo that I'm showing to you right now. This is the garden shed, which is basically there, say, built into a garden where you can keep all your stuff, gardening stuff into it. And whenever in the earlier time we want to order it, we used to do a mail to the company from where we want to purchase it. Okay, and it obviously in that time it won't fit into one package. So the what sender used to do it, they used to dismantle it. Okay, and used to send that entire garden shed into several different packages to you. And what we used to do, we used to unpack those packages and put the garden shed together again. This is an example of wherein we used to dismantle, make it into several packages, and then assemble it again. The same thing happens with the computer network as well. The computer network also works in the same way, as data is also very big to send it as a whole packet. Okay, and so it is cut down into smaller pieces, into smaller packets by the sender, and then the receiver takes all those packages and bundles it together. So in the in network, that thing is being taken care of by the protocol, who takes care of the transmission part. So let's talk about the protocols. So what is basically a protocol? If you want to communicate with someone and you want to speak a common language, for example, in this photo, and one guy is speaking in German and other is speaking in Chinese, so obviously they won't understand what they are talking to each other. So protocol is nothing but common language that you need to speak to understand each other. Like for example, in this case, now they both are speaking in English and they are able to communicate with each other. The same is true with the computers and also our network devices as well. So the term protocol, what does the term IP stand for? The IP stands for Internet Protocol. And actually the protocol has two variants, that is IP version 4 and IP version 6 that we are using for the internet communication. So in the local networks also, you must have seen that there is a protocol that is used called as Ethernet, but we also use IP. Confused, but not. There are multiple protocols that are used, and this is called a protocol stack. Multiple protocols stacked together. And you must have seen in the networking basics also that this is an open system interconnect model, also called as the OSI model. which was developed by the International Organization for Standardization, which was defined in the 1970s and 1980s. And it was basically created to be intended to be used as a vendor independent model for our network resources. But as you can see, there are 7 layers in this model, but it never took off that well. But still, it is used as a reference for teaching in today as well. So what was the relevance for it? It was intended for a working network. It had some good ideas like the separation of the layers and one layer onto building upon top of the other layer. While the OSI model was being written and was being implemented to some extent, but the internet guys were already implementing their own set of model, and already the internet was going far ahead than the OSI model. Despite all the money that OSI model and the organization had put into for the success of that model, but that never took off, and internet actually won with the internet model. So this is a comparison of the OSI model and the internet model, as you can see. And let's see what is internet model all about. It also has the same layers that you have seen in the OSI model, and the IP protocols don't exactly used to fit in the OSI model, and there was no intention basically for the IP protocol to be compliant with the old OSI model. And internet protocols are more thinking about the optimization and the architecture than considering about the layering, because the running code was the most important for them, as you can see. And it is a very simpler model and consists of only 5 layers comprising of the physical link layer, internet layer, transport layer, and the application layer. So let's first begin with the physical layer, wherein the data units are called as bits, okay, or symbols. It uses a physical medium wherein light pulses or the electrical signals are being transmitted over it. And the examples are optical transceiver and a Ethernet port. Optical transceivers are used on the fiber medium, whereas the electrical ports are used in the copper medium or the Cat5 or the coaxial cables. So next up was the link layer. In the link layer, the data units are basically called as the frames, and it is used to provide the node-to-node data transfer. And it also needed IP addresses for the interfaces. Okay, in this case, the addresses that were used are the MAC addresses. I request the audience to be on mute. And the example for the link layer protocol is the point-to-point protocol and the Ethernet. Point-to protocol, many of the ISPs might be aware that they are currently using for their broadband connections as well, where they are using the username password-based authentication over this protocol. This is the standard. And then we come up to the internet layer, that is also called as the IP layer, wherein the data units are called as packets, and it provides source to destination transport. This also needs the IP addresses like we saw in the link layer, but in the link layer there were MAC addresses, and here we have the examples of the IP version 4 and IP version 6. Then comes our transport layer. Transport layers had few features like they might provide the flow control, reliability, and the congestion avoidance features, but not all of the protocols that work on the transport layers have these features. They also contain some of the information, like I said in our last session, about the higher layer up. Okay, and the examples on the transport layer are TCP and UDP. Like you can see, the TCP has all the features that are to be offered. That's the flow control, reliability, and congestion avoidance, but UDP has none of the above. Then comes the application layer directly after the transport layers, and there's no special name for the data units for application layer. It's just called as data, and it contains all the applications layer, and the simple applications to name off is the SMTP, STTP, and SSH. SMTP is used for your mail communication, transfer of the email exchanges, and then you have the STTP wherein you use for web browsing, and there is your secure shell authentication, that is the SSH for connecting to your network devices and rest of the network devices. So in conclusion, with this session of the basics of IP, what we should remember that networks are everywhere and data are sent across the entire network into small packets. And there has to be a common language spoken between the computers, and that common language is nothing but a protocol. The OSI model defines the network as a number of layers, but the internet actually doesn't fit into the OSI model. So the internet model is currently being used. Okay, so that was to sum up with the basics of the internet protocol. Now we can start off with the actual IP. So the IP is our third topic on this networking basics series. So let's begin with it. So let's begin with the protocol itself. Like I said in my previous slide, that what's a protocol? Protocol is nothing but a common language that you need to speak and understand with each other with the rest of the computer systems. Same is the true with the networks and the computer devices as well. Then comes the protocol stack, wherein all the multiple protocols belonging to each and every protocol stack are clubbed together. To begin with the first layer of the internet stack, it's the physical layer wherein the light pulses and electric signals are being transmitted over lasers and the fiber strands. You can see an example of the fiber strand picture portrayed here and how it looks. Then comes our link layer, wherein the data units are also called as frames, and it provides node to node data transfer. Node to node, for example, you can consider like you have connected your laptop to a basic switch, then you have connected to your printer and your Wi-Fi router. This is a node to node transfer within an Ethernet segment. So this is an Ethernet frame structure, basically, like we discussed in the last session also, that preamble, destination address, source MAC address, the ether type, and the payload. So the ether type is nothing but it's 16 bits, and the payload consists of the 1500 bits of bytes of info. So what is a payload? Payload in the Ethernet is also called as an IP. It is encapsulated as a Russian doll, like IP is encapsulated within an Ethernet frame that is packed inside and packet. So whenever there is a structure of the packet flow, every protocol is being stacked up to the another protocol and it's traversing over the network. So the data units are basically called as packets on the internet layer and provides end-to-end source and destination transportation. And it also needs the addresses for the entities to communicate with each other. That being IP version 4 and IP version 6 that we are currently using as of now in our networks. So let's look at the IP version 4 header. IP version 4 header consists of the header plus the payload. The IP version 4 header varies in size from 20 bits to 60 bits, whereas the payload size also varies from 1440 bits to 1480 bits. Bits, I mean to say bytes. Okay, so this is the general structure of the IPv4 header, wherein the first part of it starts with the version. Okay, like it says the version 4, then the total length of the packet that it is being showed. Then there is an TTL section wherein it is called the time to live. Hello. There is someone on.
मैं ज्वाइन हुआ हूँ.
Okay. So I believe everyone is able to hear me. There is no disruption from my end.
Kapoor, we are getting responses that they are not able to see our presentation. Is it an error from your side?
One second, I have already shared my screen.
academic
नहीं सर लास्ट वाला नहीं दिख रहा है.
Apurva, we can see thank
Actually,
you page.
yes, your last page is there.
One second.
Yeah.
Now is it visible?
Now
Yeah.
it's visible.
Okay,
Yes.
okay. Okay. So I was talking towards the side and you guys were not able to see, but still I will run through it quickly.
Okay, thank you, sir.
Yeah. So as I said in this internet model, the link layer are called frames wherein the switches are being used. An example of Ethernet, and this is the basic frame structure. And the payload for the Ethernet is IP, where it is encapsulated within a packet into a packet. Okay. And the data units for the internet layer is also called packets, provide source to destination transport. Addresses for the entities are IP version 4 and IP version 6. Okay, so this is the header information that I was talking about. The IP version 4 header plus the payload. Okay, the IP version header consists of a variable header that is consists from 20 bytes to 60 bytes, when the IP payload also varies from 1440 bytes to 1480 bytes. So this is the general structure of the IPv4 header. When it starts off with the version number, that is the IP version 4. Then it consists of the total length of the packet, that goes up to 65,535 bytes. And then we have the TTL column, wherein TTL is nothing but the hop limit, wherein whenever you transmit a packet over the network towards the destination, there has to be a TTL value. Otherwise, there will be a continuous loop for that packet and the packet won't be discarded over the internet. Then there is a type of payload. That type of payload depends upon what type of data you are sending. May it be TCP, may it be UDP or something other. That's the protocol field in the IPv4 header. Then we have the destination IPv4 section and the source IPv4 section, wherein the destination IPv4 section consists of a 32-bit length, and the IP version 4 has a limitation of 32-bit length, wherein we have a limitation of n number of addresses. And there's an optional field also to it, that's a header length, which is used by some of the softwares if required. Then we come up to the IP version 6 header information, wherein there's a fixed header length of 40 bytes. Then we have the IP payload also, that is also fixed of 1460 bytes. This is a simpler header that you can see for IP version 6. And when you consider the IP version 6 header as a whole, that's also comprises of few fields, making it much simpler for data transmission and processing also. Starts off with the same version name and the payload length. Then the next header field is nothing but it replaces the protocol field, which I had shown you in the earlier slide for the IP version 4. It replaces the protocol field, just the name change is there. And the TTL field has been replaced with the hop limit, because actually TTL has nothing to do with the time. It has to do with the hop count only. So that's why they have renamed it to the hop limit. Then comes your source and the destination section. And now the IP addresses that we see in the IPv6 is now 128-bit in length. So let's see something about the IP version 4, how it looks like. So generally, you can see the normal structure of an IP version 4 IP address like 192.0.2.123. It's a 32-bit length of IP address, okay, comprising 8 bits of every octet, summing up to the 32-bit length of the address. Then you might have heard of the class A, class B, and class C of addresses. There is no such thing as class A, class B, and class C in today's standards. Okay, every usable IP is equal and equivalent. Since 1993, we have stopped saying that we have A class of ISP, we have B category of IP addresses assigned, or C category of addresses assigned. It's completely equal. As long as the IPs are usable, it's equal. So like I said, the IP version 4 IP addresses in 32-bit length, and these are the possible number of addresses that we have. And this IP address space is already exhausted, and no more new IPs are being allocated by the internet registries to the ISPs. Just that though the older ones which are being decommissioned from one entity is being transferred over to the another entity. Okay, and it has been denoted in the dotted decimal forms. And some of the IP addresses are reserved that customers can't use, like for multicast addresses and so on. So to come up with a solution, the IP version 6 was implemented, and it started development in the 1994. It was first published in 1995. So let's look at IP version 6 addresses. So IP version 6 addresses is 128-bit in length, and you can see such a huge number of IP addresses that you can get. That is difficult to even count also. There are a hell lot of number of IP version 6 that are available. And we don't think that there would be a scarcity anytime in the future with this if everyone starts implementing IPv6. So IP version 6 IP address use hexadecimal numbers that starts off with 0 to 9, and from A to F, comprising of the 16-bit of the octet length, and to summing up the entire IP address segment to 128-bit. And it is segmented into double colons to the entire octet, each octet with colon. And if you can see, this is an example of an IP address where it is the same IP address but denoted in 3 different ways. But actually it's the same. The preceding zeros and the consecutive zeros are just summed up in different ways that you can fill up the gaps for the zeros here. And this IP version 6 also, there are some IP addresses reserved that are not usable that you can check out for yourself. So internet, how internet all started. So let's get back in time to late 60s, where people thought that internet was generally used it was not invented to survive a nuclear war, basically, but it was invented by the Defense Advanced Research Project Agency. That is what was called as the ARPA, and it was basically used to the ARPA basically handed over these grants to the universities to create their own supercomputers at that time, so that they could share their computing power with the other entities. Okay, so ARPA didn't allow each and every university to have their own supercomputer. Likewise, they told them that you should have only one or two supercomputers and you should share your resources with the entire people. So how to share that computing resources with each other? By networks. So at that time, the internet was invented by ARPA. So just to check out with the timeline, I'll show you how the timeline was there for the early history of the internet protocol. In 1961, the concept of packet switching network was implemented. In 1967, the first internet was called as the ARPANET, as it was the first revolution at that time. In 1969, the first ARPANET node and the first RFC was published. RFC is nothing but a request to comments that every network has some of the RFC published and it's open for everyone to read. And the first demonstration of the ARPANET was done in 1972. In 1974, TCP/IP protocol was described, and the internet was named first as internet back then, and ARPANET was completely waived off. And in 1983, ARPANET switches from its old protocol, that was the NCP, that is the Network Control Protocol, to the TCP/IP protocol, and they switched this entire protocol within 1 day. But today it's not possible because we are using internet as a global standard, and no new protocol can compare with the TCP/IP. So there were competing protocols that back then also, like BitNet, DECnet, and OSEG model also, but they never took off really, because they were vendor proprietary, or just in theory those were the competing protocols, and they were not really catering to the openness of the internet and openness of the vendor proprietariness. So in the internet terms, everything is open still now, and every now and then the RFCs are being published pertaining to the network implementations or what has happened in the past, and the best practices are being published by the RFCs on a day-to-day basis. And today, it's open standard publishing for everyone. Everyone can look into it and everyone can read all those documentations. So in conclusion, there are some key takeaways that I want to tell you about the Internet Protocol. Internet Protocol is basically used for end-to-end communication, wherein the IPv version 4 and IP version 6 coexist. And IP packets consist of the header and the payload information, wherein IPv4 and IPv6 headers are completely different. Both have the source and the destination addresses field mentioned into it, wherein IPv4 is a 32-bit long addresses with the limitations of very less number of IP address space, wherein IP version 6 is 128-bit long and have gazillion number of IP addresses which we can use. And payload can nothing but another protocol that is implemented to it. Thank you. So we are open for any questions that the participants want to ask on these basic concepts. Are there any questions from the participants? Okay, how much is the attendance today for our session? So Rishabh, you want to ask something towards our audience? You are mute, by the way. Rishabh, you are mute.
Yeah, am I audible now, Apur?
Yeah, you're audible.
Yeah, so if you guys have any question, just feel free to ask.
I believe
If
some
not,
of the
that-
other participants might be knowing what exactly these all topics are there, because these are pertaining to the basic concepts for our customers. Yeah. In future, we are going to conduct more topics wherein we will deep dive into the depths of the networks. But current series is pertaining only to the basic concepts. So future more sessions also will be more focused towards the basic concept. Then we will move on to some advanced topics for the customers.
Okay, thank you
Nothing
guys.
else
Thank you
is
for
there.
your time. Yeah, I
Yeah.
hope like you found today's session as enlightening and valuable. I think Apur, we have a question. Someone just wrote something on chat.
No, they are asking about the IPv6 prefix filters. So we would be taking up this prefix filters in the later advanced topics, because this is not pertaining to the current topic, because that's a bit more into the BGP stuff actually. That is in our upcoming session. Upcoming session would be also basic pertaining to the global IP routing and to the unicast, multicast, and anycast network topologies as well. In the upcoming session on the 25th of June.
Okay, sir.
Okay. IP version 5. Someone has that IP version 5 had also came, but that was for a something different project that never took off actually. There was IP version 2 and IP version 3 also, but in our case studies and in the theory also that it is not actually taught to people because it's not relevant at the moment. So I believe there are no more questions from the audience.
Hmm.
No
Okay,
worries.
thank you guys. Thank you, Apu, for this insightful and comprehensive session. I hope you guys found it interesting and educational for you guys. I would just like to remind everyone that this learning doesn't stop. We have next session scheduled this month only, 25th, as topic has already been discussed by Apur. So I would just appreciate you to take a moment and just mention your LinkedIn ID. If you guys are present on LinkedIn, just drop down your ID on this chat here in this meeting. We can hope this it will be helpful us to mention you guys back on LinkedIn and other platforms. So this is a humble request from my side. Apart from that, I'm excited to announce that our next session will be more insightful and more in depth. So I hope that the audience who all joined us today, and we also look forward to be seeing you there on 25th as well. Thank you guys.
Thank you, Apur. Thank you for the
Thank you.
session.
Thank you, everyone. Thank you.
Yeah,
Everyone.
thank you.
Really appreciated your
Thank you.
questions. Yeah. Thank you.
Yeah,
Thank you.
it's really knowledgeable for us, and we will join again for next team session.
Thank you, Vikas. Thank you, Vikas.
Thank you.
Thank you for watching.